Hi guys, this is from the okay? Start of the motion. Now, we're looking at which one will be faster because of the fact that this is a velocity time graph. We just have to look at the actual number on the y-axis. And just so you know, this is specific to a velocity time graph or a graph. So since it does ask at the start of the motion, we have to look specifically at when when x equals 0, because x is time. And so we can see that since car A does start higher on the graph, car B, car A is moving faster at the start of the motion. So that's what we would put car A. Next one is asking which car start. Now, looking at which one ends up further, looking at the displacement, which everything ends up from. Displacement is the area underneath the graph. And so I'm going to go ahead and make it a little more clear. This area right here for car A is its displacement. For car B, this is its displacement. And so when we're comparing the two areas, we see that car B is a bigger trapezoid, and car is just kind of a small triangle. So when we're comparing the two, we can see that car B clearly takes a far more area than car A. So the answer, which one ends up further, based on the displacement and the area underneath the graph, we see that it's actually car B. Right. Last one's asking on a velocity time. You kind of have to just look at which one is the steepest. And so for that one, the one that's a fairly steep line is car A. I mean, car B may travel faster. Further. When it comes to car A, still gets to its location at a faster rate. And so for this one, car A would be the one that experiences the greater magnitude of acceleration. All right, let me go ahead and switch over to the next slide. Right, so this is one position of time, so we're confused the velocity graph, meaning the y-axis is recording something completely different. This one's asking, rank the speed of the object in each of the 4 labeled regions of the graph, from fastest to slowest. If the object has the same speed in 2 or more regions, indicate so in your ranking. Right, so for which one moves faster, the greatest amount of distance, which would be the position in meters, over time. And so, I kind of made it a little easier for you guys if you guys could just look at these boxes. Which one of these lines goes across a box faster? Right. And so right now we see that 4 has the greatest speed because within 2 seconds it moves 20 meters. Right. So the first one would be region 4. For the second one, it does seem that 1 and 3 are fairly similar. We can obviously just look at the actual position traveled over the time to make it absolutely clear that that's what the answer is. But for this one, we can see that 1 does travel these 2 boxes, and 3 travels these 2 boxes within the same amount of time and space. And so for those, the actual speed of the object is the same. And so if it has the same speed in 2 more regions, indicates so in your ranking. For this, we would put 1 and 3. And sorry about my handwriting, guys. I'm fairly well. It's kind of harder to do it here. And then the next one, the last one we have left is 2. Now, the reason that 2 would be last is because it's actually not moving. Within 2 seconds, the position it comparison to the origin stays the same, meaning it didn't actually move anywhere at any point here. And so because of the fact that it isn't moving, the speed would be 0, making it this the lowest speed. So the last one here would be region 2. So region 2 would be 4, 1, and 3, and then 2. Right. And make sure you guys indicate that 1 and 3 are the same speed. I mean, you can either just write down same speed, or you can, put it in parentheses or a squiggly line. What makes it easier, sure, clear, so you need to go away. Okay. All right. Next one is asking. Let me erase this so it's easier to read. What distance did the object and the distance include? So in the 12 seconds, that is the entire graph, since it goes from the 0 to 12 seconds. We have to add up everything. So just from 1 to 10, we see that did travel a total of 40 meters. Right. So first we would start off with the 40 meters, and then from 10 seconds to 12 seconds, it traveled another 20 meters. And so for this one, you kind of have to just do, this would just be basic math, and add up the 40 plus the 20 to how much distance, like say this, if this was a person, how much distance they actually moved. So the total, including all parts of the motion, would be 60 meters. And if you guys don't understand this, just wait till I explain C and not 40. The next one's asking, how far from the object's starting point did the object end up after 12 seconds? So this is asking, basically, if I started at 0 meters and 0 seconds and traveled, how far from my starting location did I end up? And so for this one, seconds and the 20 seconds, we just have to look as to how far away he is from the region. He, she, it doesn't really matter. So because these two kind of cancel each other out, everything kind of up in this area, we just include this much. So we see here that that's actually 20 meters. So how far did the object starting point, how far from the object starting point did the object end up after 12 seconds? We see that the answer is actually 20 meters. Right. And so if you guys have any questions, again, feel free to email me in class. I can my information at the end. Ms. Finchley did ask me to add just and I think she would give a change to the question that I'm about to ask. So let me go ahead and show you what that question is, okay? Great. The same graph, it's saying which of the following objects are either a baby crawling, a sprinter, a car on the freeway, a jet airplane during takeoff, or an amoeba in a petri dish. Now keep in mind that position is measured here in meters and time here is measured in seconds. So I kind of want you to go to Ms. Finchley, show her this question, and explain why it's whatever answer you got, okay? Right. And, I'm going to go ahead and enter information in. I'm going to give you guys a few seconds to kind of look at it, or you can pause the video, write down the question, and show it to the teacher, okay? Alright, so this is I personally want to tell you guys are actually and my email address is obi@. Right, so that should be it for this video. I am probably going to be posting multiple videos in the future to help you guys out, okay? Alright.